3D Pythagoras and 3D trigonometry. Okay, so we have a cuboid here. We're asked to find the length AG, which is that length there. Now, let me just bring this over. I think this is quite useful to see our right angle triangle here. If I join A to C, and C to G, we can see we do have a right angle triangle. So in right angle triangles, we use either SOHCAHTOA or Pythagoras. Seeing as we have all lengths here, we're going to be looking at Pythagoras for this question. Now, let's look at the right angle triangle we have. Well, we have the length GC. We do not have AG. That's our unknown. But also, we don't yet have AC. So can we find AC? Might be useful here if you have an actual cuboid just to look at it. The base of your cuboid is a rectangle, right? And if we split a rectangle in half, or through the diagonals, like this. So this is ABCD, the rectangle ABCD. We split it. Can you see you have a right angle triangle? So we can actually use Pythagoras to find the missing length AC. Pythagoras, a squared plus b squared equals c squared. Our unknown is the hypotenuse. So square root both sides. X is 12.04. So can you see now? We have AC, we have GC, so we can find AG. Let me draw it as a right angle triangle though, so you can see. So that's our ACG, that's our unknown, 20, 12.04. Again, we're looking for the hypotenuse. So when we look for the hypotenuse, we square root and square and add. I did write it out the long way here, but can you see we square, add, square root? So squared, add, square root. If we didn't have the hypotenuse, we'd do the exact same thing, but minus here, which we'll talk about if we find that situation. So x is 23.3 centimetres to 1 decimal place. Let's have a look at this second example, and then you can have a look at some questions yourself. So work out the size of angle between EC and the plane ABCD. So the plane ABCD is actually the rectangle at the bottom of this triangular prism. A plane just means a flat surface. It's still not clear which angle we need to use though. So we want let me get the line EC on. So work out the size of the angle between EC and the plane ABCD. You'll see when you're looking at finding the angle between a length and a plane, one of the points is on the plane. So C is already on ABCD, E isn't. So we simply drop a pin down a straight line from the point that's not on the plane to the plane. So to A, from E to A. And then we join it up to the point that is on the plane, which is C. And so it's that angle there, your ECA. That is the angle that we need to work out. It's the angle between EC and the plane ABCD. So we've got our triangle ECA. So let me just draw that out separately. That's the angle we're looking for. We do not have AC, we do not have EA. So we need to work both of those things out. I'm going to start with EA. Is EA in a triangle with anything else? Yes, if you have a look, EA is in a triangle with D. So we look at the triangle EAD. We can use that triangle to work out EA. So we've got that angle is 20 degrees. ED is the same as FC, 14. Our unknown is EA. Sohcahtoa got an angle, missing length, but we have a length. Opposite, hypotenuse. If I write Sohcahtoa, So, sine theta equals O over H. We have sine 20 equals x over 14. Make x a subject by timesing both sides by 14. So 14 times sine 20 is equal to x. .788. Okay, what about EC or AC? I'm thinking EC because I've just noticed we've got a triangle here, which is a right angle triangle. So it's difficult to see from the diagram because of the perspective, but EFCD is a rectangle, and a rectangle cut in half, you can see, leaves us cut in half through the diagonal, leaves us with the triangle EFC with a right angle here because it's from a rectangle. FC is 14. EF is the same as DC, which is 10. There's our unknown. So can you see it's Pythagoras? ABC. A squared plus B squared equals C squared. So 10 squared plus 14 squared, square root will give us C. .2. So we have the hypotenuse is 17.204. Hypotenuse is EC. This is what we've just worked out here, isn't it? This line. So it's not tan. We have opposite and hypotenuse again. So it's sine x equals O over H. Sine x equals 4.788 over 17.2. Sine to the minus 1 both sides. X is 16.2 degrees. Okay, I have 7 exam questions for you to look at. Maybe have a go at yourself. Put me on pause and unpause when you finish with each question. So the first question here, we've got a diagram with a cuboid. AE is 4, AD 5, DC is 8. Work out the length AG. So first of all, it's making our right angle triangle. Where is that? Hopefully you can see it is this triangle here. A, C, G. Now, GC is 4. We don't have AC, but we can find AC. There is a rectangle at the bottom, ABCD. So we have the right angle triangle here, ACD. We will use that to find AC first. 8, 5, and X. So it's Pythagoras, missing length. Hypotenuse is X, so that's C. A and B don't matter. A squared plus B squared equals C squared. So we've got 5 squared. Well, technically A is 8, I guess. 8 squared plus 5 squared is equal to X squared. So add the squares, square root. We get 9.43. Now we have our triangle GCA. Again, it's our hypotenuse is missing. A squared plus B squared equals C squared. So square, add square root. I will use the answer button on my calculator because I've got the 9.433 as an answer. So I'll do square root of answer squared plus 4 squared, which gives me AG is 10.2 to 3 significant figures, 10.2 centimetres. Okay, next question. AB is 5, AE is 6, AG, well, I assume that's meant to be our G, let's pop that in. AG is 6. No, it's 12. We want to work out the length AD. So there's our X. Okay. This is similar to the one above, but we're kind of given the answer. So sort of let's work backwards from there. So our triangle that has the 12, the AG12 on it, is AGCA. That's our right angle triangle. And we know GC is 6. So if you can see, we have 12, 6, and we'll call this Y. This time we have the hypotenuse. We're missing a shorter length. A squared plus B squared equals C squared. So we take C6 squared off both sides first, and then square root, which will give you Y. $10.39. So 10.39 here. Now AD is X, but it's the same as BC. So can you see there's that triangle, right angle triangle, that you can see from the, oh, not the best picture here, but let me just put that in to show it is a right angle triangle. We've got a rectangle ABCD at the bottom of that cuboid. So if you split it through the diagonal, you would get a right angle triangle with the 10.39 as the hypotenuse. AB is 5, BC is X. So we've got our hypotenuse, A and B is shorter lengths. So A squared plus B squared is equal to 10.39 squared. So we would take 5 squared off both sides and then square root to give us X. So answer squared minus 5 squared, square root gives me X, the length AD, which is the same as BC, to 3 significant figures is 9.11. Okay, question 3. Calculate the size of angle ECA. Let me just pop my information on. AE is 4 centimetres, AD is 5, DC is 8. We want ECA, so E to C to A. Let's just draw out that triangle to see what we have already. So we just have the 4, which is E to A. We don't have A to C. Angle ECA we need, so let me just put an X there. We can get A to C though, because can you see A to C is the diagonal of a rectangle? So we've got 5, 8 is our Y, which happens to be the hypotenuse, C, A, B. Let's use Pythagoras because you've got 2 lengths and we have a missing length. A squared plus B squared equals C squared. So we want the square root of 5 squared plus 8 squared. 9.43. Okay, so got a missing angle, so now we know it's SOHCAHTOA, we've got an angle involved. Got the opposite and the adjacent. SOHCAHTOA, opposite and adjacent is tan. So tan theta equals O over A. Tan X equals 4 over 9.433. Tan to the minus 1 both sides. X is tan to the minus 1 of 4 over 9.433. Now I can got the answer 9.433 on my calculator, so I can just carry through that answer to tan to the minus 1, 4 divided by ANS to 3 significant figures, 23.0. Question 4. So calculate the size of angle AFC. So we have A to F to C. So let's join up that triangle. AFC is that this angle up here. Let's draw out the triangle AFC so we know what we're looking for. This is F, C, and A. Okay, what information do we have? CD is 7, AD is 10, but we've got the angle on the triangle FDC is 30 degrees. So let's use that to get this angle up here, I think. So I'm going to put an X there. That's our ultimate goal. Right, let's draw out the triangle DCF. Opposite, adjacent, tan. Tan theta equals O over A times both sides by 7. Seven times tan 30, 4.04. So FC is 4.04. Okay, we also need another length. So what about AC? I can see AC. I'm running out of space here, but it is in a right angle triangle because it's part of a rectangle split down the diagonal. The length 10, the length 7, and my hypotenuse unknown. So it's the square root of 10 squared plus 7 squared because I'm looking for the hypotenuse. Let's not call it X, let's just leave it as C. Square root of 10 squared plus 7 squared is 12.2. So AC is 12.2. Then we have opposite and adjacent again. So tan X equals opposite over adjacent. Running out of space, but 10 to the minus 1 both sides. .7 to 1 decimal place. Okay, question 5. Got 3 more questions left. Diagram shows a pyramid. The base of the pyramid ABCD is a square. AB is 5, so it's a square. So I'm just going to label all these as 5. The point E is 10 centimeters vertically above the base. So I just drop that down there. That's 10. Calculate the angle EAC. So I'm going to go from E to A to C. Hopefully you can see that right angle triangle there. And this is the angle we want. So what information do we have? No, that is not the, well, okay. That's fine. We can use EAC is actually all the way across. But we can just work out that angle from that right angle triangle. That will give us the angle EAC. So we have 10. Right, okay, so we need to work out the length from A to the midpoint here. So we can work out the whole length from A to C first, because it's a right angle triangle made by cutting a square through the diagonal corners. We've got 5, we've got 5. And let's get this length here. Pythagoras, we have the hypotenuse. A squared plus B squared is equal to C squared. So we want the square root of 5 squared plus 5 squared would give us X. 7.07. Now, that's from A to the midpoint though. No, it's not. That's from A all the way to C. So we have to halve it to get from A to the midpoint, because the point E is vertically above the base. It's symmetrical because it's a square base pyramid. That's halfway along AC. Let's divide our answer by 2. Gives us 3.5355 here. So we've got that from... Okay, now we can get this angle here. Opposite, adjacent, SOHCAHTOA, TOA uses O and A. So tan theta equals opposite over adjacent. Here's my opposite, here's my adjacent. 10 to the minus 1 both sides. So y is 10 to the minus 1, opposite over adjacent. I've stored that 3.5 on my calculator, so 10 to the minus 1 of 10 divided by A and S gives us 70.5 as my angle. Question 6. So we've got a triangular prism here. Calculate the size of the angle AF makes with the plane ABCD. So let's discuss this plane again. So what does that mean? So the plane ABCD is your flat surface, your rectangle. So we want the size of the angle that the line AF makes with that flat surface. Now, A is already on that surface, so we need to drop a vertical line down from the point that's not on the surface, which is F. So we then join it to our other point A, because it's a line AF. So it's at this angle here, which is a right angle triangle. So we want this angle. What do we have already, if anything? We don't have anything yet, but I've noticed a right angle triangle here. DCF, 35 degrees. Let's put that as Y, 20. Opposite, adjacent, TOA. Tan theta equals opposite over adjacent. So is this first one divided by the second one? Times both sides by 20. So 20 times tan 35 is equal to Y. $14. So we've got one length, we need to find another length. How about we find AC? Because AC is in a triangle with D. We've got 20, we've got 30, so it's Pythagoras. I'm going to call that H. A squared plus B squared equals C squared. Or H is the hypotenuse, which is why I call it H. So A, B, so C squared equals A squared plus B squared. So to find C, it would be the square root of A squared plus B squared. $36.055. Now that's the line, this is the one here. So we've got opposite, we've got adjacent, tan again. Tan theta equals opposite over adjacent. Tan to the minus 1 both sides. £21.2 to 3 significant figures. Last question, question 7. Diagram shows a pyramid. The base of the pyramid is a square. AB is 15. Calculate the volume of a pyramid. You're not actually given this formula. So you're meant to know the volume of a pyramid is a third times area of base times the height. Okay, well, we already have our area of the base. It's a square. To find the area of the square is 15 times 15. So area of ABCD, 15 times 15. Okay, times the height. Now, what is the height? Let's have a look. So, this is similar to a question we've already looked at. If we drop a line down vertically from P, we get this right angle triangle. A, P, M, I'm going to call it. I'm going to put an X here. That's what we're working out, the height. What do we actually know from this information here? Oh, we know angle PAC is 65 degrees. I did not spot that before. So PAC is the same as the angle PAM anyway. So I can pop that on. And then if we see AM is half of AC, so let's just find AC first of all. So we've got A, C, D. Let me just draw that more in the orientation that we have it already. Pythagoras, let's call that Y. That's our hypotenuse, AB, A squared plus B squared equals C squared. We're looking for the hypotenuse, so it's the square root of A squared plus B squared. 21.2. That's the whole length AC, so we need to halve it to get AM. Oops. £10.6. Using the whole answer on my calculator. And then we've got SOHCAHTOA to find X. We've got O, we've got A, we've got tan again, TOA. Tan theta equals opposite over adjacent. So times both sides by 10.6. So 10.6 times tan 65. X is 22.74 as my height. So 22.74 times 225 times a third. Volume of the pyramid is 1,706 centimetres cubed.